If you have your own, bring it. Only see him if you do not have one of your own. Thank you.
All right. So we're simplifying the fraction by canceling factors that match. 5 is a factor of 15. 5 is a factor of 35. So that's why those two cancel out. We normally, we just think about, well, divide both of them by 5. That's really what you do. But when we start looking at expressions like this, where we have x times x plus 3 over 10 times x plus 3, that looks a lot different. It's not quite, straightforward. It's not a regular fraction like we're used to with just numbers. We've got factors. On the top, you've got a factor of x and a factor of x plus 3. On the bottom, you have a factor of 10 and a factor of x plus 3. Which factor matches? So that's the one that cancels. So that it ends up just being x over 10. So the name of the game is cancel a matching factor. So we're going to have to factor some things today, use our factoring skills that we have learned over the course of the year to do some stuff with. Okay? Okay. All right. So before we get too deep into this, let's talk about these things called excluded values. Because this is something you'll have to find before you even simplify. Excluded values. They are also called restrictions or restricted values. You might see them called restrictions on the domain. What they are the numbers that would make the denominator equal 0. Because we want to find these because those are the only, that's the only number we can't divide by. We can never divide by 0. That's not a defined operation. So we need to, when we have x's in the denominator, we're going to have excluded values, things that x can't be. It's going to be the numbers that would make the denominator equal 0. And one important thing that you want to do is you want to find them before simplifying. Okay? Before you simplify, you're going to find your restrictions or your restricted values, okay? Or excluded values. Different, context, they got different names depending on what you're dealing with, okay? So, let's start doing a few problems here. We're going to find the excluded values It's a bird. It'll be okay. If we shut the door, it's going to get hot in here. I'd rather have the air with the bird than not. I'm sorry, the air conditioner does not work. So, no, it blows hot air, not cold air. Okay, so we're going to find the excluded values and simplify if possible. Okay. So example C, let's do this. X plus 8 over x plus 8. Now, before we simplify, I think we can see that there's something that's going to cancel. It's real easy to see that. We got a factor that's going to cancel. But before we simplify it, we've got to find the excluded values. And we'll just abbreviate those. We'll call them EVs. We're going to set the denominator equal to 0. to find the excluded values, you just take that whole denominator and set it equal to 0. And then solve it. So to solve that, I would divide by 12 to get rid of that. And then that gives me x plus 8 is equal to 0. And then I would subtract 8. And x is equal to -8. The excluded value would be x cannot be -8. You just change that to a not equal to. Just equals and then a slash through it. So that's the excluded value. That number would cause this fraction to have a 0 in the denominator because -8 plus 8 is 0. 0 times 12 is 0. So that's what messes this fraction up. We can't divide by 0. So we've got to find that before we simplify. Even if that factor is going to cancel out, because we see that factor of x plus 8 is going to cancel, but we still find our excluded values before that happens. Okay, so if this factor and this factor cancel, what's left on top? 1. It's just like if you had 3/6. What does that reduce to be? 1/2. If everything on the top cancels out, then there's a 1 left there. If everything on the bottom were to cancel out, there'd be a 1 left there. Okay, so we have a 1 on the top and 12 on the bottom, and that's it. That's simplified. All right, excluded values, find them first, and then simplify. All right, so let's look at this one. 2x plus 6 over 8x. Let's find our excluded values, or value. Set 8x equal to 0. How do I solve that? Divide by 8. X equals 0. So the excluded value is x cannot be 0. X does not equal 0. Now, to simplify this problem, we've got to think about factoring. So we look at the numerator and the denominator and see if we could factor either of them. Well, the denominator is only one term, so there's no factoring that happens there. But what about the numerator? How could we factor 2x plus 6? The GCF would be what? 2. 2 goes into both of those, and that would leave x plus 3. And then on the bottom, we have 8x. Then I look at that and say, oh, I have a 2 and an 8. Both of those are divisible by what? 2. So I'm going to divide them both by 2. And that's going to leave me x plus 3 on the top. Technically, it's 1 times x plus 3, but 1 times something just gives you back whatever you started with. Then on the bottom, 2 goes into 8 how many times? 4, and we still have the x. That is the simplified version of that. This x here cannot cancel that x there because they're not parts of matching factors. They have to be matching, perfectly matching factors to cancel out. Okay, since this has a plus 3 on it, this has the 4 on it, they're not matching factors, so they can't cancel one another. That's why we're going to leave that x in the denominator and in the numerator. So that's the simplified form of that. The factors have to match completely to cancel anything. All right. Let's look at another. $20 over 2x plus 10. Same instructions. We're going to find our excluded values and then simplify if we can. Excluded value. How do I find that? Set the bottom part, the denominator, equal to 0. And solve it. What do I do? Subtract 10. 2x equals -10. Divide by 2. -5. So the excluded value is x cannot be -5. X does not equal -5. That's our restriction, our excluded value. Uses all those names. Now, the next thing to do is try to simplify. In order to simplify a rational expression, you want to think about factoring. So which one of those factors? The 2x plus the denominator, the 2x plus 10. How does it factor? All right, so the first thing we always look for in factoring is the greatest common factor. 2 would be that. What would be left in the parentheses? X plus 5. Okay, so we have a regular 2 out in the front and then a 20 on top. Do those have anything in common? They're both divisible by 2, so divide them both by 2. 20 divided by 2 is 10. 2 divided by itself, 1. So all I'm left with is x plus 5 on the bottom. Using the same idea as we did on the last problem, we're going to leave the 10 and the 5 in there because they're not matching factors. This is a plus x plus 5, so it's tied to the plus x there. And this 10, it's not really tied to anything, but this one's tied to the plus x. So you can't just cancel out parts. You have to cancel out matching factors. Four x squared plus 12x over 4x. So we're going to find our excluded value. How do we find that? Okay, so 4x is equal to 0. So x cannot be 0. That one's pretty easy to solve. And then I want to think about factoring the fraction, factoring all the parts of it that will. So the top part, will it factor? What's the GCF? 4x. What's left in the parentheses? X plus 3. Now, what matches? The 4x and the 4x, they cancel each other out. All that's left is x plus 3. What's on the bottom, technically? A 1. It's over 1, technically. You don't have to write it as over 1. You just leave it x plus 3, like that. If the 1 is on the bottom, you don't have to write it. If it's just a 1 on top, you do have to write it. Okay. Excluded values. How do we find those again? Bottom part equal to 0. Now it's got x squared plus 2x is equal to 0. How do I solve that?
Subtract x squared.
I got 0 on the other side. No, I don't need it over there. I could factor it, yeah, with GCF, right? X squared and 2x have what in common? X. Leave x plus 2 in the parentheses. And then what do you do with each factor? Set each factor equal to 0. And solve those. So this one's already done. X can't be 0. And then this would be x cannot be -2. There's 2 excluded values on this one. And that's okay. It's not a big deal. Those really come into play.
X squared have anything to do with there being 2?
Has everything to do with there being 2. If it was x cubed on the bottom, you'd have 3. Yeah. So whatever the degree, whatever your exponent on your x is, that should tell you how many excluded values you're going to find. It's exactly tied to that. Okay. The good thing about it is I factored that. I'm going to have to factor it anyway, right? To simplify. So factoring is going to be the vehicle you're going to use all day, on all of this stuff. So on the denominator, I've already factored it as x and x plus 2. I just need to factor the numerator now. How do I factor x squared plus 7x plus 10? The x method, that's right, because it's a trinomial. So I need something that multiplies to be 10 and adds to be 7. 5 and 2, positive 5, positive 2. So my factors would be x plus 5 and x plus 2 on the top. What cancels? The matching factor of x plus 2 on top and bottom cancel each other out. Yeah, x plus 5 over just x. And remember, we cannot cancel this x because it's tied to the plus 5. Got to cancel the whole factor if you're going to cancel it, if it's tied together with addition or subtraction. Okay. All right, so kind of pulling some factoring back in. Let's look at this one. X squared plus 7x plus 12 over x squared plus 6x plus 8. Again, we're going to find our excluded values. How do we find that? Set the bottom half equal to 0. That's exactly right. That's a quadratic. I've got several ways to solve it, but what method do I think would be beneficial? The X method of factoring. Factoring is the way you want to do this. I know you could do quadratic formula and get the solutions to that, but you're going to have to factor it anyway to simplify. So, need something that multiplies to be 8 and adds to be 6. 4 times 2 is 8. 4 plus 2 is 6. Since it has a 1 in front of x squared, I can go straight to my factors. X plus 4, x plus 2. Set each of those equal to 0. X can't be negative 4. And x cannot be negative 2. Again, the exponent on the x was a 2. We ended up with 2 excluded values. That's not a coincidence. That's always going to be that way. All right. So we've already got the factored form of the denominator. So I'm going to use that. And then I need to factor the numerator. So I need something that multiplies to be 12 and adds to be 7. 3 and 4. Since there's a 1 in front of x squared, that means I go straight to my factors. X plus 3, x plus 4. What cancels? The x plus 4 that matches. And that leaves you x plus 3 over x plus 2. And again, you cannot cancel these two x's here because this one's tied to a plus 3. So that means it's different than this one that's tied to the plus 2. Okay? Don't cancel individual x's unless they're a matching factor with the denominator. Okay. So far, so good. X squared minus 9 over x squared minus 3x. Again, we're going to find our excluded values. How do we do that? Bottom half equal to 0. And I've got an x squared in there, so I want to try to solve that using factoring. And it's not a trinomial, so I don't use the x method. What do I try to do? GCF, which would be x, leaving you x minus 3 in parentheses. Set them all equal to 0. And solve. So x cannot be 0, and x cannot be positive 3. Those are my excluded values for this one. I've already factored the denominator when I went to solve it, so that saves me a step. How does the numerator factor? It's only got two terms and a minus sign in the middle. X squared minus 9. 9 is what kind of number? It's a square number, right? Because it's 3 times 3, right? So that's a difference of squares. So how does that factor? Good job. X plus 3 times x minus 3. Then what cancels? Yeah, that matching factor, the x minus 3's. Leaving you x plus 3 over x. Factoring, factoring, factoring. What you have to be able to do here. All right. Let's look at this one. 5x over 5x squared plus 15x. Excluded values. So how do I find those again? 5 equals 0. How do I want to solve that? Factor it. So how do I factor 5x squared plus 15x? Well, it's not a trinomial, so I can't use the x method. GCF is the way I'm going to do that. What's the GCF? 5x. What's it leave in parentheses? Good job. X plus 3. And then what do I do with each of those? There you go. And equal to 0. So this one would be x cannot be 0. This one would be x cannot be negative 3. So I've got the factored form of the denominator. That's the only one that has to be factored. What cancels? 5x on top cancels the 5x on the bottom. So that leaves an x plus 3 on the bottom. What's on top? 1. Everything on top canceled. So there's a 1 left. Bam. We just got a couple more here, guys. We're easing through this. X minus 4. What you need? Okay. All right. So x minus 4 over 4 minus x. It's kind of a strange looking one. What's wrong with the denominator? It's not in descending order. So we want to write it in descending order. So I'm going to rewrite that. X minus 4 over negative x plus 4. That makes it look more like what we're used to. Okay. And then when I go to find my excluded values, negative x plus 4 equals 0. And we can solve that without factoring. We just subtract 4, negative x equals negative 4, and then divide by negative 1. And x can't be 4. But it's not going to help us simplify since we didn't factor it. So we got to think when we go back up here, factoring, to get something to cancel out. Because this one will simplify. The numerator doesn't factor. But what could be factored out of the denominator to make it look like the numerator? A negative 1. Because when we put it in descending order, that puts that negative out in the front. If we pull out a negative 1, that changes the sign of both of them. And that leaves it to be negative 1 times x minus 4. And that lets us cancel the x minus 4s so that it's 1 over negative 1, which is just negative 1. as an answer. Okay. So, all right. We got time to do this last one. It's not very hard. X squared minus 7x plus 12 over 16 minus x squared. What's the problem with the denominator? Not in descending order. Put it in descending order. All right. Excluded values. Hey, I don't really like that word. Just what? You too. No, you weren't interesting. All right. Now, excluded values, we're going to set the denominator equal to 0. Now, I know what happened on the last problem, so I'm thinking I probably need to factor that. So what would I factor out of that? -1 to get x squared minus 16. And x squared minus 16 will factor how? Difference of squares. We'll finish this after lunch, guys. Have a good lunch. All right, so when we left, we had factored this denominator by pulling out a -1, and then we had a difference of squares. X squared minus 16 factors is x plus 4 and x minus 4. And then we're going to solve that. So I'm going to get rid of this -1, and that's going to give us x plus 4, x minus 4 is equal to 0, and then set each of those equal to 0. And that's going to give us x equals -4, or that's what x can't be, and this one would be x can't be positive 4. Okay. The key to this one is the fact that that's the factored form of the denominator, not this spot, but right here with the -1 in front. If you drop the -1, then it's not the complete thing from the original. So you got to have that -1 in your factored form. So when you go up here to your factoring of the original problem, you're going to have -1, x plus 4, x minus 4. And then in the numerator, we need something that multiplies to be 12 and adds to be -7, which would be what? -3 and -4. So that's x minus 3, x minus 4. And then cancel out the part that cancels. And there's x minus 3, or -1, x plus 4. And just leave it in the factored form like that on the denominator. And that's it. Factoring, they're not going to be extremely difficult factoring problems for you to do in this section. The idea is just to get back into factoring a little bit more and then cancel the matching factors. That's what your job is for all this stuff. It's not extremely strenuous. It's page 797. Let's do 3 through 10. On those 8 problems there, just find the excluded values only. And then on numbers 13 through 32, find the excluded value and simplify. So 13 through 32, you're doing the whole thing. On 3 through 10, you're only finding the excluded value. You don't have to simplify. Just find the excluded values on 3 through 10. Okay? And that'll be your job for today. And guys, I know it's getting hot in here. I wish there was something I could do about it. We just had to deal with it.